right, so to continue on, we're going to go through the overview, and then, so we did that already, flow measurement technologies, how mag meters work, talking about flow meter applications and product review, and then we'll end with some questions. So we'll start with, what is flow measurement? Well, the definition is the measurement of a liquid or gas through pipes through a known diameter or open channel. So that's what we're trying to figure out. Now, if we think about the equation for flow, it's, you know, velocity, it's velocity times area gives us our flow rate, right? So how much, what's the velocity of the product that's moving, and what area is it's moving through? That gives us our flow rate. Why measure flow? Well, you know, we want a visual indication of system status, or maybe we want to control something, right? We want to go in there and react to changes in process conditions. Maybe we want to data log. Maybe we want to record these flow measurements. It could be, you know, streams, rivers, pipes, you name it. But we want to actually be in compliance, or maybe it's a product quality, or maybe there's another reason we want to do that. Or, you know, as you see with the gas pump, maybe it's for billing. We want to make sure that we measure that gasoline down to the drop at $5 a gallon right now, or worse. Some people from Seattle are looking at $5 going, we wish we had that. I saw a picture of a 7-Eleven. Their price was $7.11 a gallon. That was hilarious. They predicted that one, right? So how do we measure flow, right? So there's a lot of different ways to go at that. We could look at it through differential pressure. We could look at a vortex. There's the Coriolis effect. There's thermal mass. We could use ultrasonic. That's used quite a lot. You can use a mechanical turbine. Just have like a paddle wheel moving, and we can clock its rotation. But how we're going to talk about it today is electromagnetic, right? And this is the technology we use. How do mag meters work? So we have one out on our table out there that you guys can actually take a look at. It's almost an exact model of this. Electric coils are placed outside the flow, are momentarily energized. Boom, we hit them with power, right? Magnetic field crosses the flow at right angles. So there you go, there's the flow coming through at a right angle. The motion of the conductive fluid moves through the field, generates a small amount of electricity as in a generator. All right, so those coils get some electricity based off the water flowing through it. Right, they're not even in contact with it, but that's the principle of it. So more flow equals a higher voltage. So if we look at it in this term, and in this picture, here's our flow rate. It's pushing through the pipe, it's going past those coils, and because of that field that we're generating around the water, we're actually getting an electrical current back from the water flowing through it. And that's what we're actually detecting, is that changing current. The electrodes measure the changing voltage. So we have electrodes that are sitting there going, oh, hey, you know, the voltage changed, this is what's going on. Increasing flow, electrodes sense the changing voltage. It increases. The display unit shows the rate in total. So in between there is the board and the microprocessor and the algorithms that are taking that current and then turning into what that flow rate is, right? So that's the, you know, the magic in the box, as it were. That's where that goes through. This is what the display looks like. So we get our total gallon, we get our rate in gallons per second, and that's how your display works. Now you'll notice there's connectors on this display. That means this display can actually be hooked up to other things. So you can have units that just display, or you can have things that hook up to other things. So let's talk about some advantages and disadvantages on these. The advantages in using a mag meter like this, where there's nothing in there that's impeding it, there's no pressure loss. We're not having something impede and create a back pressure. There's no moving parts. Moving parts can actually, if they're in the flow, can be a problem. Maybe there's something in the process stream that can gunk them up, right? Like oil and gas or something like that can actually gunk up moving parts. They're bidirectional. Doesn't matter which direction the flow is going, we can detect that. Short piping requirements. We don't have to have huge long runs for what, you know, for some instruments like Doppler technology requires sort of a laminar flow to it. So we can actually have shorter piping runs and bends closer to the meter if we need them. And they handle a large volume of different types of flow media. Disadvantages. Fluid must be conductive. So that's one thing. If it's not conductive, the mag meter is not going to work as well. Most mag meters require a full pipe, most. We do have some that do not, but most do. And are sensitive to stray voltages and currents. So if something's going weird with your magnetic flow meter, take a step back. Is there something that could be inputting a voltage or a current to it? So that's something you'd want to look at. But it's your first choice for clean, reuse, and wastewater. I mean, when you think about it, if it's wastewater, there's moving parts, junk gets in there, you can mess up the flow meter. So there's some certain advantages to it. So next we're going to start talking about some applications. A great application is landfills and leachate, right? That's definitely going to be conductive fluid. It's liquid produced from rainfall and decomposition of waste in the landfill. When the landfill gets filled up enough, what do they have to do? Pump it out, right? You can't go forever. It's collected by these sumps and it's pumped to a central holding pond, tanks, or tank trucks. So anyone that's been out to DIA knows there's a landfill right there. It's quite visible, right? Lots of pumps on there. In fact, they dewater to a water truck. So they have a system set up where they're like pumping into a truck. The truck is there so often picking up fluid. If you look at the map of the landfill, and I think it's still the same map, you can actually see where the truck fills up because you can see it right up on the landfill. It's there that often. It's unpredictable though, production, right? So, these pumps are going to turn on their own and start running because they detected enough fluid. Well, it's nice to have a flow meter out there to also say, okay, not only did it turn on and start pumping some fluid, we pumped this much fluid. Meters helpful tool for total leachate transfer, treatment, processing, so that it gives us a lot more management data and stuff like that. Mining is important. I know we talked about this earlier on the sensor thing. Mining is not just about production, it's also about safe, right? We want to keep a mine safe and we want to keep it in production. When we have a pit mine, that's true on both, right? We want to keep the water level down so we can keep an operation, but if water keeps coming in and it's coming into the wrong areas, it can soften the mine walls and cause issues. And you can actually have sloughing or landslides within the mine. So you want to keep your water dewatered. So it's important to pump and remove the water and continue mine progress and keep personnel safe. You can get totalization of amount of groundwater removed and transferred for regulatory purposes. So if we have a mining site and we're producing water, that water is being discharged, the regulators want to know how much of that water we're discharging, right? Especially out here in the West, water is itemized, it's owned, it's quantified, and if we're adding to a stream or river or something like that, we have to calculate that input and report it. In addition to quantifying water removed, flow meters give us feedback on pump performance. So, okay, say the pump's always running at this speed, but the flow keeps going down, 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 down. Well, we know our pump is probably losing performance, right? So it gives us some feedback on that. Oil and gas. Oil and gas sites produce water through drilling actions and production. The extraction of wastewater must be measured and quantified. These are produced water permits, once again. If you're producing water on an oil and gas site, and even if it's going to an evaporation pond, you have to quantify how much you're putting into that evaporation pond. We talked earlier about how pressure sensors can be used on those evaporation ponds to know how full they are and when they've drained so you can actually fill them again. Well, that's important in that regards. There's also on-site treatment systems. So maybe they're treating the water. Well, that treatment system is going to have a flow rate requirement, and it's good to make sure you're not overdoing it. Geotech here makes shallow tray air strippers. Well, those air strippers can only meet a certain flow requirement. If you're running too fast through one of those in that treatment system, you're not going to be effective on treating it. You can overdo it with the carbon treatment and filtration treatment. So flow meters really help out with that. So if there's any discharge from that treatment process, once again, to a stream, river, or back into the ground, you again have to quantify it. Remediation systems, this is what I was talking about. This is one of those Geotech air strippers, all right? Total fluid systems, pumping to carbon treatment, air strippers like the one shown here, oil water separators, and groundwater extraction systems for below surface treatment all have a flow rate requirement to them. And if we're not measuring that accurately, we could actually do damage, or we're not going to be effective in our treatment. So when it comes to remedial processes, flow rate does have a big influence, and being able to quantify that is very useful. So when we look at our solutions here, this unit here is called an IMAG 4700. The unit, we can do them down to a 2-inch all the way up to a 12-inch pipe. As you can see, it's a flanged model. It's battery powered in this version. IP68 submersion burial rating for the housing. Multiple available outputs. That means we can actually take the data from this and tie it into other systems, whether it's a SCADA system, control system, RTU, or just even a data logger. You can take the data from this unit and the signal coming from it and use that. Easy to use menus. It's just a touch. It's a touch screen or a touch button on the screen there, and you can see the up arrow and down arrow right there, so you can move through the menu. Telemetry ready, and a durable polypropylene liner with 3/16 stainless steel electrodes in it. So it's really durable. It's designed for rough water to go through it. It has all kinds of stuff to it. But so that's one of our flagship products right there. Next is the WMP. This is a smaller version. This unit is a battery-powered version. They're 1 inch to 3 inches in size for pipes. They're simple, a cost-effective solution. They give you flow rate in total. There's a pulse option for it, so they can give you a pulse reading on it, and that's what some data loggers will take as a pulse. And based off that pulse, they know what the flow rate is. It's a polypropylene body with stainless steel electrodes. So a little bit smaller, but still pretty durable little unit, and has a lot of different applications for it. Next is the next little smaller unit is 2 meter ranges. It's a PE202. Flow rates down to 0.03 GPM, which is really good. It's a really nice little low flow tool. It's Kynar PVDF wetted materials. It's chemically compatible to a lot of things. It's pulse or 4 to 20 milliamp output on it. What's really nice about this for like even sampling and monitoring sites is its fittings and adapters go from 1/4 inch to 3/4 inches. So if we're at a site and we're doing a pumping test or something like that, this would be a great little meter to pick up to actually get some data on our flow rates while we're out there. So that's really the whole presentation. It goes pretty quick. It's pretty simple to understand. So we're going to go to questions. Do we have any questions on magnetic flow meters? Yeah.
The conductivity of the water, how would that affect the flow management? If
Well,
the water is more.
Well, once again, because we're putting an electric field through the water, we're encircling it.
Yeah.
If there's nothing conductive in there to change that magnetic field, then we have an issue that we're not going to generate like the current in those coils that we need.
Yeah, but if the water is seawater, is it gonna create more eddies, or a higher voltage effect?
No, that won't affect it. No, it's if like, let's think like glacial runoff where it has like nothing in it, or distilled or deionized water. It's so clean.
It's
Yeah.
more concerned of having a minimum conductivity.
Okay.
Yeah.
So typically 0.5 micromodes, microsiemens
Yeah.
conductivity.
Micro 5 is like.
Yeah, but if you go distilled or deionized water, like ultra clean water, which does occur naturally, right? There's some areas on the planet where that does happen. We run into that. I used to do a lot with Doppler flow meters, right? If you didn't have enough seeding material in them, like, so you'd have people doing glacial runoff, and even the Doppler meters couldn't even touch it because there was nothing in it, right? It's just too clean, especially when they start getting into those pre-industrial age areas where the glaciers are melting, right? There's nothing in there, right? You know, maybe some pollen, but nothing really to make anything, right? Yes.
That last meter you showed, it fits on the outside of the tubing.
Yeah, that's a male pipe thread. So you thread the tubing onto there, or thread a barb onto there, or an adapter.
So is water like flowing through it then?
Yep, that's correct. And that's your connector, so right here's the fitting, and right here's your connector for output.
Gotcha.
It's pulse and 4 to 20 current. But what I like about this unit is this right here. If we think about the tubing sizes that are most commonly used for sampling and monitoring, or just for pumping tests, if you're using like a ready flow tube pump or something like that, the most common discharge off that is 1/2 inch, right? So that gives us an opportunity to measure that for different pumping. Anything else? Well, that's all I got. Like I said, it's a pretty quick little presentation, but if you guys have any other questions, we do have a booth. We're over in the corner in the hall right there. So if there's anything that comes up or any questions that you have, just let us know and we'll be more than happy to answer them. And like I said, we have that one out there. It's got a different display on it, but we got that meter out there.
Thanks, Jason.
Yeah.